Hey guys, this is the first lesson for Algebra 1. This is on algebraic expressions. And so by the end of this lesson, you should be able to evaluate, simplify, and write algebraic expressions. This will all be review. If you took Foundations of Algebra, we did this in Foundations. If you did not take Foundations, you still did this in 8th grade math. So most of this will be review, and it's very simple. It should make for a nice, easy first lesson for you guys. So an algebraic expression is a mathematical statement that contains addition, subtraction, multiplication, and or division. They also have variables. So if you remember, a variable is a letter. Variables are unknown values represented by letters. Parts of an algebraic expression go by certain words. And so it's important for you to know those, because when you take your state test in May, they may ask you specific questions about the parts of the expression. So parts of an expression separated by addition or subtraction symbols are called terms. So you could see a question that says, when simplified, how many terms does the following expression have? And you'd have to be able to count those terms. So like this one down here has 1, 2, 3 terms. In addition to terms, most algebraic expressions have multiplication in them, and the parts that are being multiplied are called factors. So like 2 and x are being multiplied. 2 and x are both factors of that term. 2x and y are being multiplied. 2x and y are both factors of that term. 3 and y are being multiplied. Those are both factors of that term. So a number factor that's numerical, is called a coefficient. So it's very likely that on your state test, and on your test on this for me for sure, they may ask you what is the coefficient of the second term of that problem. And you would have to be able to identify the coefficient as -2, because that's the coefficient, the number term in the second term of that problem. So your coefficients are 2, -2, and 3. Now later on we'll study how to name things like this that have multiple terms, but we'll do that when we do polynomials, so I'm not going to go into that right now. But you need to know term and you need to know coefficient at this point. So you could be asked to evaluate algebraic expressions, you could be asked to simplify them, or you could be asked to write one from a verbal statement. So we're going to look at evaluating them first. Evaluating an algebraic expression is basically just a calculator trick. Evaluate means to solve it for a specific value. So if you're asked to evaluate, all you have to do is substitute the value they ask for into the expression and solve it. So you replace the variable. I got lost in what I was saying. You replace the variable with its new value by removing the letter and putting its number in its place within parentheses. This is called substitution. Then you can either use PEMDAS, or you can just use your calculator, which is what I'll recommend, because we're really, especially on our state test, going to be pressed for time. And so calculator will be your best option there. Just use your calculator to solve it. So, for example, in this one down here where they tell us to evaluate this expression for n equals 3. That means everywhere there's an n in this, I'm going to replace it with 3. So I'm going to go 3 in place of the first n. I'm going to keep the parenthesis in the 5. Where the next n is, I'm going to put a 3. What I want you to notice about what I just did here is that everywhere there was an n, I replaced it with a 3 in parentheses. Here's another n, I replaced it with a 3 in parentheses. Everything else that was in the original problem is still there. I still have the parenthesis in the 5 that was here. I still have the minus 13 parenthesis root exponent of 3 here. But I just replaced all of that with the number that they asked me to substitute. Now, if you're at home and you don't have access to a calculator that'll do exponents and stuff, you can use your Desmos calculator app, and it'll calculate things like this for you. And I'm actually going to pull that up so you can see it, because I know there are quite a few of y'all that are in that boat. And even like a cell phone calculator, it'll do exponents, but it's kind of weird to try to do it. So this might be a better choice for you guys overall. So here's Desmos. Desmos works just like a normal calculator. You can type anything you need to in right here, and it'll calculate that value for you. If you need exponents and stuff, you can use this little keyboard thing that's right here, and it'll allow you to create exponents. So I'm going to do, I wish I could shrink this, but if I can, I don't know how. So anyway, we're going to just let it be like that. It's just big and taking up the whole screen. Maybe. Trying to move it, y'all. Failing epically. Hello. Well, let's do that and put it back. Sorry, guys. I don't know what. I'm having a hard time there. All right. Anyway. Now I can move it. It wouldn't let me touch the correct spot. So I'm going to do 3, 5, 3. This is not convenient. Minus 13. And then to do an exponent of 3, I'm going to use this button, because that lets me make an exponent of anything I want. This will automatically put a 2 up there. This will make whatever I want it to be. So, and this was supposed to be 13, wasn't it? 13, exponent 3. And then it'll automatically give me a value. See in that box where it gave me the value of 24. So this evaluated is equal to 24. That's what they mean when they say evaluate. All right, let's look at another one. So these ask us to evaluate these expressions for 4 and 7. So for this one, I'm going to do 7 times 4 plus 3 times 7 minus 12. And you might be like, do I really need all those parentheses? Yes, you do. Because if you start subbing things in without parentheses, and especially when they're negative, you run into situations where the answer is going to come out wrong because you didn't put parentheses around it. So make sure that you're using parentheses around anything you sub in. Don't let those parentheses take the place of parentheses that are already in the problem, though. Notice here's my x. I replaced it with 4. Over here, here's an x. I replaced it with 4. Here's an x again. I replaced it with 4 again. And in this next one, here's a y, so I replaced it with 7. And I'm getting those numbers from up here, by the way, y'all. If you're like, where did she get these numbers from? They're up there. And then here's a y again. I replaced it with 7. What I want to point out to you before I actually go and do the calculation of this in Desmos is that here I kept the 7, the plus 3, the minus 12. Here I kept the 2. I kept the parenthesis in the 3, the subtraction, the 4, the parenthesis, and the 2. So I'm going to have a double stacked parenthesis here. That feels weird, looks kind of strange, but it's necessary to be able to make sure you're going to get a correct answer to these. So anything that was originally there has to stay, plus whatever new thing you need to put in there as well. So I'm going to do this one, 7 times 4 plus 3 times 7 minus 12. And again, it calculates that and gives me a value of 37. So this is evaluated to be 37. Now we'll turn around and do the other one. Two times 4, parentheses 3, parentheses again 7, minus 4, parentheses 4. Close the parenthesis and then an exponent of 2. And I get 200. That's evaluating. We're solving them for a particular value that's given to us. You cannot evaluate unless they give you a value to substitute in. We'll do one more together and then we'll let y'all try a couple of these. So for this one, 3, in place of x, I'm going to put 4, plus 2. In place of y, I'm going to put 5. In place of z, I'm going to put 3. So again, notice that I took the x, put a 4 in its spot, because that's what this said. I took the y, put a 5 in its spot, because that's what this said. I took the z, put a 3 in its spot, because that's what this said. Everything else that was originally there is still there, including the 3 in the square. Notice the square is outside of what I subbed in. The 2, the cube on the outside of that 3 that I subbed for z, and the final parenthesis. All right, so I'm going to calculate. 3 times 4 squared plus 2 times 5 plus 3 to the third power. Close the parenthesis at the end. And I get 85. By the way, you can type those in Desmos using your keyboard. If you want to make an exponent while you're typing, you can just push the up caret that's on the 6th key, and it'll go up to the exponent for you, and then you just arrow over to get back out. All right, we're going to go to the next slide. And I'd like you to take a minute and try to evaluate the 2 on this slide, and then go to the next slide and evaluate the ones on that one as well. I think there are 4 on that next one. Yeah, so evaluate the 2 on this one and the 4 on the next one, and then come back and see if you were correct. You can just evaluate them, pause the video, evaluate them, and then come back and check them, and then move on from there. All right, take a look at these. If you missed them, pause the video again and look back at mine compared with what you did. See if you can see where you messed up. Maybe you made an error in what you typed in. Maybe you forgot a parenthesis somewhere, something like that. And then go check the next page against these and do the same thing. If you missed one of them, pause the video real quick and take a look at it and see if you can figure out where you made a mistake. Especially like in one like this one where there's a lot of parentheses. And then some exponents and stuff going on. You might have messed that up, or even in this one, kind of the same thing. So if you did mess it up or miss it, go back and look and find your mistake so that you can make improvements on that. All right, now let's look at how to simplify expressions. So this, again, is all review. Simplifying an expression means to make it smaller. So what we do is we find a way to take something that has a lot of terms and condense it down into fewer terms. That's what we mean to simplify. So when we simplify, we do 2 things. We start by looking for distributive property to eliminate parentheses. Distributive property is what we use to multiply what's on the outside of the parentheses by what's on the inside so that the parentheses can cancel out. So use that to eliminate the parentheses. Then you're going to combine terms that are alike. So combine like terms. Like terms, remember, are terms that have the same variable and the same exponent. So that's stuff like x squared plus 3x plus 2x squared plus 3. Out of this list, the only ones that would be considered like terms would be the x squared and the 2x squared, because they have the same variable with the same exponent. You combine like terms by adding them together. Okay, so let's do a little bit of practice with this distributive property. So we're going to actually take this kind of step by step. We'll do a few with just distributive property, a few with just combining like terms, and then we'll look at what happens if we put it all together. So with distributive property, or if you're looking at an expression and you see these parentheses in it, you know you're going to need to do distributive property to simplify it. So what we do is we take what's on the outside and we multiply it by what's on the inside. Numbers multiply to numbers, and letters would multiply to letters. So 7 times 3 will become 21W, and 7 times 5, or negative 5, is negative 35. And since one's a W and one's not, we can't put them together. So that would be the simplified form of that expression. Now, B does the same thing, but B is written backwards. They've put the 4 that's being multiplied on the back instead of on the front. If I saw this problem, I probably would just take that 4, move it to the front, and then I would distribute it the same way. So 4 times 6 will give me 24V squared. 4 times V, remember this V by itself is a 1, so you do 4 times 1 and get 4V. And then 4 times negative 3 is negative 12. Again, we have a V squared, a V, and something without a variable at all, and so we can't combine those. So we'll just leave it like that. That's the simplest form of that one. All right, here are a few more. I'm going to work one more of these with you and then let you pause the video and come back and see if you can get the other 3. So I actually want to look at B, because B has some negative numbers in it, and I want to make sure we understand kind of how that's going to work. So if you were going to distribute with B, you would do negative 6 times R times 3 and times negative T. So negative 6 times 1R would be negative 6R. Negative 6 times positive 3 would be negative 18G. And negative 6 times negative T, remember this gets read like negative, would be positive, because a negative 6 times a negative 1 becomes positive 6. So plus 6T. So take a second, pause the video right here, and see if you can work the other 3 doing distributive property, and then unpause the video and see if you got those correct. Okay, so take a look at these. Hopefully, you're able to come up with the same answers that I got as you worked through them. If you didn't get the same thing that I got here, stop the video and go back and redo them and see if you can see maybe what you did wrong. Especially pay close attention to your signs. Like in this one, make sure you have a negative 15 and a positive 25 and a negative 10, because that negative 5 changes the signs of everything that's inside of these parentheses. So you want to make sure that you end up with the correct thing. We put positive 25 here because negative 5 times negative 5 comes positive 25. So we use a plus to indicate that. Anyway, hopefully you got all those right. Let's take a look at some where we're just combining terms. So here, if we're going to combine terms, remember we have to look for things that have the same variable with exactly the same exponent. So in this very first example, it's really, really simple. We've got a 17U and a 25U being added together. They're considered alike because they have the same variable U with the same exponent. There's not an exponent, it's understood 1. So we're going to add together these like terms to combine them. So 17 plus 25 will give me 42. And then the U just stays U. It's kind of like we're saying 17 umbrellas plus 25 umbrellas to get 42 umbrellas. We don't do anything else to that U. It just stays. So in B, I have a 6T squared, a 3T, and a T. The only things we can combine are this positive 3T and this negative 1T, because they have a plain T with no exponent, or an understood exponent of 1. We can't combine them with a T squared because they don't have an exponent on either of them. So T squared's the only one like that, it stays. These can go together to make this smaller, make it simpler. So when I give my answer, I'm going to keep the 6T squared, and then I'm going to combine 3 with negative 1 to get positive 2T. All right, let's go on from there. So take a minute, pause the video right here and try these 4. Combine like terms and fully simplify the expressions. Then unpause the video, come back, see if you were right. All right, take a look at these and see if you got these correct. This one was really, really simple. This one actually could not be simplified. Nothing could go together here. So it just stayed exactly the same. And these you are able to put together your Y's or your A's on these sections, and all the other pieces just came down as a part of your solution there. So if you missed any of them, go back and make corrections to those. And let's go look at somewhere we've got to do both. So if we've got to do distributive property and combine like terms, we want to look for distributive property first. We always want to handle that multiplication before we try to combine terms in that. So when I look at this one, I've got 3x, and then we're adding 7 times 3x plus 4. I'm going to do the 7 times the 3x plus 4 before I deal with that other 3x that's being added. So I'm going to bring this 3x down, and I'm going to multiply this. 7 times 3x makes positive 21x. And then 7 times 4 is positive 28. And then from there, I'm going to look for those like terms that can go together. So I've got a 3x and a 21x that'll go together. So that gives me 24x plus 28. Okay, let's take a look at this next one. We've got distributive property and addition happening in this one too. So we're going to start by multiplying that 4 times the FG and the 3G. The 5G that's outside the parentheses doesn't get multiplied, so it just comes down as a part of our answer, or a part of our next step of this. But we do that multiplication with the front of that. So 4 times FG would make 4FG. 4 times 3G would make positive 12G. And now from here, again, we look for like terms. Like terms have to have the exact same variable and exponent. So 12G and 5G can go together. The FG cannot because it has an F in it. So 4FG plus 17. G, sorry. All right, take a look at this next one. Now this one, we don't have to do distributive property. There's no parentheses, so we don't need to try to multiply something when there's no need for multiplying. So don't assume that you have to do both all the time. You're only going to multiply when there's parentheses and you need to. So for this, we're just going to look for the things that are alike. So I've got a 3a and a positive 2a that are like terms. They both have an a. And I have a 5b squared with a 4b squared. That'll be able to go together because they're both b squareds. So 3a plus 2a will give me 5a. 5b squared plus 4b squared gives me positive 9b squared. And that's all we have to do that one. We only combine terms. There's nothing to distribute there. All right, and then look at this last one. This one is a little bit tricky because we see this part in parentheses, but there's not a number out in front of it. We've got a minus sign out in front of it instead. This 4x is not being multiplied by this because the subtraction symbol separates the 4x from the parentheses there. So if that happens and you have something in parentheses but no number, you need to add an understood 1 in front. And then you can multiply that. So I'm going to multiply a negative 1 times 3x and a negative 1 times positive 1 to do the distributive property part of that. So the 4x that's in the front and the negative 2 in the back don't get used. They're just going to come down as a part of our next step. So 4x comes down, negative 2 comes down. I'm going to multiply the other. So negative 1 times 3x is negative 3x. Negative 1 times positive 1 is negative 1. Then again, I'm going to look for like terms. Distribute, then look for like terms. So 4x and negative 3x would be alike because they both have an x. Negative 1 and negative 2 would be alike. So I end up 4x plus negative 3x is positive 1x. Negative 1 and negative 2 together would make negative 3. So 1x minus 3. You also could just write this as x minus 3. When your coefficient is 1, you don't usually put a 1 with it. All right. Whoa. Take a minute, pause the video, and try these 4. and then come back and see if you were correct. All right, take a minute. Take a look at your answers from these. See if you got the same thing that I got. A was really simple. B was pretty easy, but you might have noticed that when you combined your 6 with your negative 6, you got 0. So you can write that as 0x minus 10, because negative 2 times 5 is negative 10. But really the better way, the more simplified way, would be to just drop that 0x altogether, because 0 times anything is going to always become 0. So really just negative 10 would be the fully simplified form of that expression. And then here you just combine some terms, and here you had to distribute and then combine. But that was all pretty simple, I think. All right, let's move on. So the last thing we need to do is be able to write expressions from verbal descriptions. And so I've made this slide so that we can include some words that are common for all of these different operations. Because the hardest part of this is to figure out what all these different words mean. So when you're having to write an expression, you want to look for words that indicate what operation to do. And what symbols to use. So some common words for these different operations. So for addition, we know that if it says add, obviously that's addition. I'm not going to put the word add on the list because that's silly. But if you see the word combine, that means put it together. The word total a lot of time means addition. Obviously plus, together, sum. Those are all words that mean to add. Now, that's not every word that could mean add, but that's some of the most common ones. So when you see things like that mentioned in your problem, you're going to think, okay, I need to add here. Subtraction, you might see things like minus. You could see less. Speaking of, go put more on the list for addition. You could see reduced. Or reduce. Take away, obviously, I'm not going to put take away on there because that feels a little bit silly. But things like that. And then the word difference. That's the mathy word for subtraction. And there are more words than that, but that's just some common ones. Multiplication, obviously times. Or words like twice. That would mean times 2, right? The word of, we don't always think of the word of, but of is a multiplication word. Percentages are always multiplication. And if you have a number followed by the word each or per, that indicates you need to multiply by that number. And then the word product, that's the mathy word for multiply. Division would be things like split. Division means to split it into groups or groups. Divided, obviously, but I'm not going to put that on there. The word quotient. And if the word per is part of the question, then that means you're going to need to divide to figure out how many per whatever. So those are your 4 operation words. And again, there are more things that could go on these lists, but this is just a few to kind of get your minds wrapped around what to think about. In addition to that, you also need to be able to recognize if your problem needs parentheses or if you've got exponents in your problem. So if we're looking at parentheses, parentheses means something has to happen before something else. That's the whole purpose of using parentheses. So if we want to look at this in terms of, I'll slide that over a little bit, things that have to happen before other things, we can recognize that in a word problem by looking for things that say like the sum or difference followed by the word product or quotient. Because if you use the word sum or difference, before you use the word product or quotient, you're going to have to put that in parentheses to be able to do sum or difference before you do product or quotient. So things like that. That's not real common, but it does happen. And then exponents, words that will indicate exponents, obviously to the power of. So if I said 4 to the power of 5, or to the 5th power, you would know that was an exponent. Other words that tell exponents are things like square. We know square means to an exponent of 2. Or cubed means to the exponent of 3. So you want to be familiar with those. And then I have a box here that says turnaround words. There are two things that you see sometimes that indicate you have to reverse what is actually written. The word less than and the word subtracted from. So if you had something like 5 less than x, you really write that as x minus 5. Less than is what we call a turnaround word, so it makes us have to flip it. Or if you had 5 subtracted from x, then you actually have to write it that way, where you subtract the 5 from the x minus 5. So be aware of those two turnaround words, because that's going to change the order that your problem is written in, and that makes a difference for subtraction. The order that you subtract in matters. So you want to make sure that you have that in the correct order when you write it. Okay, so let's look at a few examples of these. I'll zoom back out so you can see all that if you need to. So here we're going to write some algebraic expressions for these verbal expressions. So A says a number t more than 6. So when I read this, I want to identify things that represent the variables or the numbers that have to be in my problem, and then things that indicate the operation, more than for this one. More than tells me I'm going to add. So my expression is going to be t plus 6. You also could write that as 6 plus t. That would be correct. Take a look at the next one. 10 less than the product of 7 and f. So I've got 10, 7, and f. And then I've got less than, and I have the word product. Now I know less than means to subtract. I also know less than is a turnaround word, which means I'm not subtracting at the beginning, I'm going to subtract at the end. Product means to multiply. So I'm going to subtract 10 from the end after I find the product of 7 and f. So if I'm going to do 7 times f, the simplest way to write that is just to write 7f, like that. You could also do it with parentheses, like 7 times f, or you could do 7 dot f. That's not very common for algebra. Usually it's going to be in parentheses, or it's going to just be side by side. But you could see it with a dot, maybe. And then for C, it says 2/3 of the volume V. Now, it looks like there's not really a word in here that tells me what operation to do, but there is. Of is an operation word that means to multiply. So I'm going to do 2/3 times V. All right, let's keep going. Here we have two different examples. So this says, how can you write the verbal phrase, the quotient of 5 and the quantity 3 more than a number n, as an algebraic expression? So I've got 5 and 3 more than a number n. Then I have words like quotient, quantity, more than. So I know quotient means to divide. Oops. And then I have more than that means to add. So when you divide for algebra, you typically show that as a fraction. And so the quotient of 5 and 3 more than a number n. So 5 and 3 plus n. And that would be how I would show that quotient. The word and is usually the place where you separate the two things you're doing. So if it says the quotient of this and that, that's kind of your separator there for what goes top, what goes bottom. If it said product of this and that, it would be 5 in the beginning and whatever's after the and in the end. So just kind of use that as your separator. All right, next. Last month, Landry volunteered 20 hours at her town library. In the weeks to come, she plans to volunteer 5 hours per week at the library. Write an expression to represent the total number of hours she will have volunteered W weeks from now. So now we have some story problems, but we still want to kind of treat this the same way. So we're going to go through and find our numbers. 20 hours, 5 hours a week. Go find some of those words that help me know what to do. 5 hours per week. Per is one of those words. We want a total W weeks from now. So if we're looking for a total, I said total usually means to add. So that means we're probably going to be combining something. So if she volunteered 20 hours at her town library already, and she's going to go 5 hours per week, per with a number means multiply. So 5W. They tell me down here to use W. So 20 plus 5W would represent her total. All right. Here we have another one. Or another couple. Connor earns a base salary of $500 a week, plus a commission of 12% of sales. Write an expression for his total weekly salary if he sells D dollars of goods. So he makes $500 a week plus 12% of sales. And we're looking for total weekly salary if he sells D dollars of goods. This is a little bit tricky because you see the word per with that 500, and it's going to make you think you need to multiply. But if the variable in this is representing dollars of goods, we don't need to multiply that with $500 per week because weeks is not what our variable is. Our variable is dollars this time. So since this is going to represent his total weekly salary, he's going to get that $500 once a week. And on top of that $500, he's also going to earn his commission. It says plus commission of 12% of sales. Your percent is where your variable is going to go, and that's always the case. Your percent always gets your variable in algebraic expressions. Oh, they said use D. Let's use D. The trick, though, to that is that when you use a percentage in an algebraic expression, you can't write the whole number percent. So if it's 12%, you don't write it in there as 12. You change it to its decimal form to use it in an expression. So 12% as a decimal, you move the decimal twice to the left, or you can divide it by 100 if that helps you. And so we're actually going to use 0.12D, not 12D. And that will apply every time you have a percentage. You don't ever use a percentage in its whole number form in the problem. You always move the decimal in it. Samaya owns a jewelry shop. In her shop, she pays P to purchase a necklace wholesale, but she sells it for the wholesale price plus a markup of 33%. Write an expression for the retail price of the necklace. So again, I've highlighted my words that are my things that tell me what numbers or variables to use. I'm going to look for some words that tell me what else to do. So I have she sells it for the wholesale price plus the markup of 33%. So I'm going to look at how to put this together with addition because it says that she sells it for that and we're looking for her sale price. So what she pays for it plus the 33% markup. So again, we're going to change that percent to a decimal, 0.33. And then even though we've already used the P at the front, we have to use it here too because that's a percentage, and a percent always needs to multiply by your variable. So P plus 0.33P. Now that actually can be simplified. if you wanted to give the simplest form of it, because this P is really 1P, and 1P plus 0.33P could be 1.33P. So you could simplify that one. You cannot simplify the one about Connor because you have 500 and you have 0.12D. They're not alike, but you could simplify this one into 1.33P. All right, let's do a couple more. And then I'll let y'all try a couple of these together. Isaiah takes his friend to lunch. He pays D. I said y'all try them together. I'll let you try it on your own because you're obviously watching this video, not in class. Isaiah takes his friend to lunch. He pays D dollars for the meal plus a 15% tip. Write an expression to represent the total amount that he pays. So I'm going to go find my numbers, find my special words like plus, total, and then I'm going to put all of that together. So if he pays D dollars for the meal plus 15% tip. So 15%, again, is going to turn into 0.15 before I can actually use it. I've got to move the decimal 2 times to the left. And since it's a percent, I put a variable with it as well. The word total and that word plus both told me I needed to add here. So D plus 0.15D. You also could simplify that into 1.15D. Either one would be an acceptable answer. Okay, go ahead and pause the video and try to write one for Rayleigh. It's very similar to the last two that we did, so you should be able to put this together. And then unpause it and see if you were correct. All right, so take a look at this and see if you're able to come up with the same expression that I got. So I had her base price plus her percentage of tax, and then I actually simplified that to make this. Check your percentage and make sure that you use this, because if I move that decimal 2 steps to the left, I get 0.075. So it goes from being between 7 and 5, 2 steps left, to 0.075. That's a little bit different than the other ones we've seen because it was already a decimal, but you had to continue to change it out of a percent. All right. Take a look at this one about Berta. Berta and her family are going on vacation to New York City. While there, they will see a play and attend a concert. Berta buys T play tickets for $14.50 per ticket and T concert tickets for $22.50 per ticket. So they want us to start out by writing an algebraic expression for the total cost of play and concert tickets. So we know that word total tells me I need to add these things together. And so I have up here that there are play tickets and concert tickets, and they want to call them all T. T play tickets for $14.50 and T concert tickets for $22.50. So if I was going to write an expression for that total, I would show that you would do $14.50 T, because that's how much it is per ticket, and per tells me to multiply, plus, because I'm getting a total, $22.50 T again, because per tells me to multiply. Now, these are like terms. They can go together. So I can add $14.50 and $22.50 to simplify this into 37T. Then they ask us to use this expression to find the cost of 8 play and 8 concert tickets. So I can either use the $14.50T plus $22.50T and plug 8 in for the ticket for both, or I can use my simplified one and plug 8 in right there for T. I'm going to do that because it's a little bit easier. And I get $296, I think. I don't have a calculator on me right now, y'all, so you have to forgive me. Yeah, 296. That's right. Okay. One more. Mike is buying supplies for school. He buys P packages of paper at $3.50 per package and P packages of pens at $2.50 per package. Write an algebraic expression to represent his cost for paper and pens. Take a minute, pause the video, and try to do A. Don't try to do B and C yet, but just try A, and then come back and we'll check and see if that's right, and then we'll look at B and C after that. So pause the video, try to write one for A, and then come back and see if you were right. Okay, so take a look at that. I put 350p plus 250p and combine that to make 6p. That would be the total for paper and pens together. Now, B says Micah buys 2 fewer packages of pencils than packages of paper. Pencils are $1.50 per package. Write an expression for the cost of pencils. So if they're $1.50 per package, and we know that he buys 2 fewer packages of pencils than paper. So we don't know how many packs of paper he bought, but from the statement at the very top, it tells us he bought P packages of paper. So when I use this 2 fewer packages of pencils than packages of paper, I'm going to remember that he bought P packages of paper, and we need to subtract 2 from it to show 2 fewer. So that means P minus 2 could represent the packs of pencils that he bought. So if they're $1.50 per pack and he bought P minus 2 packs, I need to multiply P minus 2 times 150. So it's really not any different than us multiplying 350 per pack times P for the number of packs, but now it's 150 per pack times P minus 2 for the number of packs. And this can simplify using distributive property. So I can get 150p minus 3. Because 150 times p would be 150p. 150 times negative 2 would be negative 3. And then they ask us in part C to use these expressions from A and B to write an expression for the total cost of paper, pens, and pencils. So take a second, pause the video, and see if you can come up with an expression using what we got for A and B to write a new expression for total cost of all of it together. And then come back and see if you were right. All right, so take a look at yours and see if you got the same thing that I got. What I did is I just added the 6p with the 150p minus 3. And I simplified that into 750p minus 3. Okay? And that is the end of that lesson. Y'all have a beautiful day.